Hi, I'm Tom and I talk about code. Welcome to a bit of an awkward stream. My microphone stand just broke, so I'm sitting weirdly. My posture isn't very good. I don't know how long I'm going to last with this stream, but we'll see how we go. There are some things I want to stream today. There are some things that have really been on my mind. Okay, in this stream, I want to rework how we set up our frame buffers, and I want to rework how we start and end a frame. That's going to mean that we can pretty much completely divorce ourselves from PS2 SDK draw code, and that means that we can own everything from start to finish completely in Lua. Now, we could technically do that right now, but I want to actually implement it right now, right? So we're going to jump across and do just that. I don't think there's too much to say. We just need to start looking at this code and start thinking about it. While we have a look, while I get this up, I will just quickly say that one of the main things motivating this for me is that I really want this to be like start to finish Lua, because then I can start to use this more as a teaching tool, I think, right? I would love to walk through building this up purely in Lua from scratch in a video and actually kind of teach these PlayStation 2 concepts rather than just blasting through them in a stream where we kind of like, you know, make it up as we go along. So we're going to pull up the PS2 SDK source and we're going to jump across 3D test. We have this math branch. Now that's a problem. Main. Hold on. Awesome, I'll just chuck a really poor commit message in there, and then we'll get a branch. We'll call it Lua frame start, because that's the main thing we're going to do. So if I go into, I guess let's just load up one of our examples, right? If we open up the rectangle example, we do a few things when we start up our program, right? We have to set up our frame buffers and Z buffer. Then we call this GS set buffers function. Now, GS Lua set buffers. This does a little bit of stuff. This stores some stuff in a graphic synthesizer state, right? We have this GS state. And this state, this stores our actual frame buffer and a bit of information, and we use these graph functions. Now, I don't want to re-implement these in Lua, okay? I want to keep these graph functions, I want to keep them. I want to keep using them. But these draw functions, we can re-implement ourselves, right? Draw setup environment, this just sets a few registers in GS, that's easy. Set the primitive XY offset, also very easy. I know what these involve pretty much without looking up the source, but we will look up the source just to be safe. Draw finish, you know, again, that's easy for us to do. So all this does is put some stuff into a buffer, then kick off a DMA transfer. We can do this. We can do this in Lua. It also does an alloc and a free, which is a bit weird. But we only call this once, so that's fine. Just want to set output. So set output. Set frame buffer filtered, set mode. So we've got to call this as well. And we call that down here. So again, this is fine. Set output is fine. These are just graph functions. So anything that starts with graph, we're going to keep. Anything that starts with draw, we're going to get rid of. Yeah. So cool. So all this GS state, this is only actually used in this one function. We set it up because this one function here wants to take arguments in this specific structure. That's wasteful. Maybe wasteful is the wrong word, but we can do better. We can actually do this in Lua. And I don't ever think we need a C implementation of this because it's just going to be something we do once, right? We call this once at the start of the program. We don't care about performance. We can do this slowly. We can do this in leisurely Lua. So that's awesome. That's really awesome. And then the other thing that's going to happen, we draw 2D frame start and draw 2D frame end. If we go into draw 2D Lua and look at how frame start is implemented, you can see that it calls this frame start function on a buffer, right? So, where is it? Buffer Lua frame, start frame. Cool. So start frame does a few things as well. Again, it's going to relies on this Z buffer structure, draw disable test, which is not, again, this just sets one register. And then we do some stuff here. Pack gift tag. Set tag of impact. Cool. So we manually set this test. Wait, hold on. Draw enable. See, I don't know why we do this, right? So draw disable tests. This is to do with zbuffer stuff. We disable the z-test, but then here we also do it manually. So I think this is a bit of legacy stuff, right? And this is the kind of thing I want to get rid of. This is the kind of thing that bugs me. This is just sloppy. And then we call draw clear. Now draw clear does a bunch of stuff. And actually, if I run, let's have a look at what I get when I run. I need to put trace logging on. So if I go to our texture example, info level, let's put it on to trace level. And if I run this, we're going to get, you know, the ever-loving crap spammed out of this, out of our logs. So if we look at this, right, DMA tag, we get some like setup. This might be, yeah. So look at this. Okay. Remember how I said we were like duplicating work, right? Like we were calling a draw function which disabled the z-test. That's this part of the draw buffer, and then we did it manually, and that's this part of the draw buffer. It's the same thing. So that's good. That is very, very good to see. And then this is the start of draw clear, because this sets up some special registers and then just draws like a bunch of rectangles. Now, this is important, right? When we clear the screen on the PlayStation 2, the PS2 SDK version, right? So if we have like our screen, if we have our rectangle, PS2 SDK, rather than just doing what you might expect and filling the whole thing in one color, it actually draws a bunch of smaller rectangles that are filled in, right? Why not just draw the whole thing? What is the difference? I don't know. So we need to work this out. Why smaller? Why does this matter so much? And we can crack that. Right? But so then everything after this point, everything after this point is just the normal frame. So we need to replicate this every single frame. And that's beautiful, right? That's not hard to do. I was just looking at microphone stands. Let's get rid of this. My microphone stand's broken. My microphone stand is broken. We're gonna have to do something about that. Mad Supervillain, welcome. Welcome to the stream. So we've got some stuff to do. I think that's a good definition of the problem. So let's start with frame start, right? Because this is a little bit more obvious, I guess. So we can get rid of the Z buffer, right? Because this was being used here, and we can just do that. We can just get rid of that. If we build this and rerun this, if I run Docker and then build this and rerun this, run Docker run. It's starting up. It's thinking really hard. It's thinking really, really hard. And now if I build and then run, this still works. It's still absolutely happy because that was being duplicated. And actually, let's check and see if that bit I said was being duplicated is gone. And it's still being set twice. This is still being set twice. That's not right. Did we definitely build? Hold on. Looks like everything's up to date. Could I say give a plus? Weird. This really should no longer do that twice. I'm also making an assumption about what register. What is it? Register 47. So we can go in here. What's the file? GSGP, I think. And I want to look for 0x47. 0x47. GSRegTest, yeah, so the test register. This is the graphic synthesizer register that controls things like alpha testing and depth testing. And so this is the register that we're setting here, but we're setting it twice. Why are we setting it twice? Why do we have two GIF tags that set this thing? And it's being set to the same value twice. That's a little bit wasteful. I would rather not do that if possible. So let me just rebuild and rerun one more time just to make sure I'm not going crazy. And it still gets set twice. That's weird. That is weird. Wrench test. Okay. So also worth noting, this is something that's going to have to change in the future because we're going to need to be able to control these different flags, right? You know, the alpha testing stuff, the z-test method. This is actually going to be important when we're doing 3D. For 2D, it doesn't matter. We're just disabling tests, basically. And that's great. Either way, this still works, and that's what I'm more concerned with right now. So now we just need to re-implement draw clear. And again, we can actually do this we can definitely do this just in Lua. So let's try it. Let's go into draw2d. Draw2d.lua, okay? Let's change our example. Right, let's go to a simpler example. Let's go to our rectangle example. So, you know, a much simpler draw buffer. Let's go into egrect and let's change our log level to log.trace level. Cool, so let's have a look at the draw buffer for this, right? Much simpler. So if you look at clearing the screen ends here. This is what we're putting in. This is what we need to replicate. Okay, much simpler. Oh well, this is what we need to replicate. The first bit is just saying like there are 29 bits in this DMA packet. So like basically it's saying that there are like 20. It's saying that there are 30 lines in this part. Well, hex 30 anyway. God, numbers are complicated. So I mean, one thing we can actually do, right? We can come into draw2d Lua frame start. So all this information is actually in just in our draw2d state, right? There's nothing extra we need. Or is there? 204 RGB. There isn't. 100% of what we have is here. So this GS argument is actually never used. Isn't that weird? Like, this has really been a bad frame smell for me for quite a while. A bad code smell, sorry. This frame handling stuff, right? There's just weird stuff going on that shouldn't be here. So let's do this. Let's get rid of this argument, right? It's gone. And now, instead of actually calling into this, let's just do this ourselves. So the first thing we do, okay, we set, what are we doing? GIF, how do I do this? GIF dot tag, GIF dot tag. Where's a good example of me doing some GIF tag stuff? Sub to above, GIF image, GIF dot. Let's find our triangle draw. Cool. GIF dot. So do I just do a tag or do I actually make this the? I'm probably gonna add a higher level version of this. Okay, so let's go GIF tag. Make a GIF tag. I lost my line. Where am I? GIF tag. We put it into the buffer. It's a GIF packed. It has a size of 1. It's not an ender packet, and we're setting something via the A&D register. The A&D register, we're just like copying stuff into a register on the graphics synthesizer. It's very straightforward. And then we're gonna say GIF dot whatever. GIF. We want function GIF test. We want to set the test register. It literally just called register test. That's beautiful. Cool. So we have a buffer. We're gonna have a z-test mode, and that's gonna be all. That's gonna be all for now. Let's head over and let's grab the hardware manuals up and just see what actually goes into this register. Test this. Perfect. So 18 bits. Very easy. And we're going to set the top 2 bits of these 18, or I guess 19 bits. 2 bits. Depth test method. Depth test on. Oh, okay. I was going to say, can we just disable the depth test? But apparently this is not allowed. Very scary. Very scary wording, right? What does that mean? What happens if you do this? Who knows? But yeah, if you're interested in how the testing works, by the way, I've read this quite a few times now, right? So alpha testing. You can change the way alpha testing works. So like you test against transparency. So pixels with an alpha less than the reference alpha will pass the test. You can like do all this interesting stuff. You can set an alpha reference. So you can hard code an alpha value that then like filters against other alphas. It's very cool. It's very cool. Yeah. Very cool. So we want to set the bits 17 and 18. We want to set them to 0, 1. Okay. So, well, we want to set them to whatever we pass in, right? So 0, 0, 0, 1, 1, 0, 1, 1, right? Between 0 and 3. So let's go GIF set AD P B. We're going to set register test And we're going to set this to, so the lower 32, right? So it's going to be ztest times 2 to the 17. And then 0. That should be it. That should be what we need. So gif test, yeah, sure, why not? That sounds good. And then we just need to go into gs.lu, what's it called? What's this called? PS2 const.lua, that's the one. Register test equals 0x47. And I really should sort these at some point. It's going to be very confusing working with this like horrifically unordered list, but this will do for now. So if I go into, what is it? Draw 2D, Lua, gif, test, self buff, and we're going to say 0x10. No, we're not. We're going to say 0b10. We're going to say 2. And if I run this now, it looks like that did not change anything. Why not? See, something weird's going on here, right? Surely. Because I changed this as well, and this has not taken an effect. This has not taken an effect. So what's going on? Oh, this is because I'm using the C renderer, not the Lua renderer. So if I go into rect, I say PS2 prog. I've got to enable the Lua renderer. Right, we're testing around the Lua renderer, and here we go. So that's what we expect to see, right? We expect to see some garbage. It doesn't look pretty, it doesn't look good, but this is correct. And this is correct because, you know, if we look at it, right, we're setting. Okay, we're setting, this is a different value we're setting it to, but we're setting the z-test to be disabled. And then we're doing our normal drawing. So we're missing the clear out from here, right? If we go back into draw 2D, you know, this did this test set, but then it clears the screen as well. So here's what we're going to do. We're going to go gif, tag, self buff, gif, packed. We're going to do one loop. It's not going to be the end of a packet, and we are going to use the sprite no, we're going to use the rect format. We're going to make a new format. GS registers to set when drawing colored. All right. Well, I guess we can do it. We literally have a function for this, right? Let's do it. Let's just go. Where are we? Let's not do anything too fancy. Let's just draw a triangle, right? So let's mark this rect. So literally just self-rect. I didn't set a mark, did I? And then we'll say, yeah, self-rect. We're going to draw a rectangle from 0, 0 to 6, 40, 448. And let's see what happens. And it all comes out red because we didn't set the color. So self set, what have I called this? Set, literally just set color. We're going to go 0, 0, 0. And floor number expected. Bad argument number 1 to floor frame. Draw 2D Lua 108. Bad number. 108. We didn't set a we didn't set an alpha. Perfect. So we'll set the alpha to 0x80. That's what we've always done. Nice. Then we can draw against a black background. So this seems to work, right? This seems to work absolutely fine. Why does PS2 SDK do this weird clear? Let me ask on Discord right now. Let me just like send a message. PS2 SDK channel. I'm going to ask this question right now and see what we get back. Awesome. Well, so we learned something valuable today, right? We can apparently clear the screen in a less complicated way. Now we just need to, instead of this, what do I do? Color. We've got a clear color set somewhere, right? Where does this, hold on, frame start? We have it literally here. Self.clear R, self.clear, self.clear R, self.clear G, self.clear B. Beautiful. And now this works exactly like it did before, it seems. So that's great. That's great news. That is great news. Isn't that so much nicer? Isn't that so much simpler? And now, when we come into PS2 init, I think, we should be able to say fast draw2d dot frame start. We should just be able to copy this across from... Oh no, hold on. We can't quite just pull this in for the C renderer because of this. This state won't exist in the Lua renderer if we're using C. So we're not quite into using this in C yet. I think we can, but there's just a little bit more work to do. Just a little bit more work to do. Or maybe we just keep it a little bit slower, a little bit more cumbersome in C for now, right? I'm more concerned with having the option of doing it very minimally in Lua. But ideally we should keep this completely compatible where possible. So let's have a look what happens in frame end, because frame end does a little bit more stuff, right? Frame end. End frame, sorry, there we go. So, frame end. Actually does not do as much as I thought it did. Let's find the definition of what's it called? Draw end. Draw end? Draw finish, sorry. Okay, so this creates a GIF tag that's the end of a packet, and it sets the finish register to 1. That's all you do, by the way, to denote the end of a draw to the graphic synthesizer. You just set a magic register to a magic value that happens to be 1, and everyone's happy. So let's just do that instead. Again, I'm passing this GS table. What does this do? Push string head get table 1. Draw buffer is in arg number 1. Yes. And we never do anything with argument number 2. We can literally just stop passing this, and I run, and it's fine. Why have we done this so cumbersome, in such a cumbersome way for so long? That's insane. I cannot believe this. Erect. Let's get rid of it. He is gone. He's out of here. Look at this. Look at this. Now we're getting lean. Now we're getting powerful. Frame end. You're going in the bin. All we're going to do is say gif tag self.buff gif packed 1 false. Except this is actually going to be true. This is going to be this is the boolean that controls whether this is the end of a packet or not. This is the end of a transfer. This is the last thing we do in a draw, and we say gif dot finish, and that's it. Gif. We haven't already done it. Function gif finish. And we don't take an argument here because the only thing we're ever going to do is just set this to 1. Then we just need to go to PS2 const finish. I believe this is 0x61, but I'll need to double check. 0x61, he's good. He's learning his PS2 magic numbers. Alright, that's beautiful, that's beautiful. So, if we do this now, right, is this just gonna work? Is this just gonna happen first time? I really hope so. I really hope so. What happens if I run? That looks good. That looks good. That's amazing. And there we go. We are cut loose in Lua World from PS2 SDK. Now, if I go over to the C version of this, okay, draw2d.c, frame start. So this is good, right? This is just using magic macros. Draw to say, okay, so hold on. I can do this again. I can get rid of this again. Draw clear. We've learned that we can actually do this simpler. So we can go pack. No, not pack gift tag. We can go, yeah, pack gift tag, right? Gift set tag. I really hate the way this is done. I hate that pack gift tag is used both for creating a gift tag and for setting values of a gift tag. I see why they've done it, but I hate it. Gif, what am I doing? I basically just want to draw a triangle, right? So, I guess this doesn't really play nice, does it? It doesn't really play nice. I could... Okay, this is like a little bit of extra stuff to think about that I don't want to have to think about right now. Frame end, this is easy. So I did this without PS2 SDK. So it's really, it is just this line. This is the only line left. Not of all of PS2 SDK. We use a lot of PS2 SDK. We love PS2 SDK. Let's just check this diff real quick. So this is all good. Need to get rid of that. This is looking fantastic. I love everything about all of these Lua changes. I love these C changes as well. This is a great simplification. Let's do it. Let's go back to our rectangle example. And let's get rid of this and let's check out what was happening in that buffer. Because remember I was saying about the duplication that confused me? And it looks like it's still there because I didn't rebuild. ZB defined but not used. That is a good error. That's the kind of thing we want to see. We want to see this cruft from before, defined but not used. And we can see we're now only setting register for 7 the one time here. The duplicate bit is gone. I don't know how well this shows up on stream. Hopefully the text isn't too small. This is as big as it goes, right? Yeah. Unfortunately as big as it goes. But hopefully you can see, right? We've cut back on some duplication. I love it. I love it. Okay. So where do we go? Simplify, frame, start, end in draw 2D Lua. Now let's have a look at draw2d.c. Draw2d.c. I want to come into where I'm using these big cumbersome functions, right? So gif packed, where is it? Frame start. I'm doing all this bulky stuff, and if you look, right, we actually have functions that do this. Much like on the Lua side, we have functions that handle this complexity. So rather than, packing a gif tag by hand, we can actually just say gif. We can actually just say, if I can remember what it's called, gif tag new. We take our state. We take 0, 1, 0 gif. Just some magic numbers here to set up a gif tag that has one thing in it that is not the end of a packet, that is a gif packed where we're setting the AD register. And then we say gif tag, we say gif. Have I called all of these functions gif tag? Hold on, it's in buffer.c. Gif tag. I probably shouldn't have called all these functions gif tag. I guess they're part of a gif tag, but yeah. Int gif tag test AD test. So set the test register when we're working with an AD, when we're setting it through the AD register. Struct d2d state s. We're gonna just take in this test for now. We probably should do the full thing, but I'm feeling lazy. Gif AD s. We set the register test, and now we're gonna go shift. What is it? Shift. Test 0x3, it's 2 bits, and we shift it across by 17, and that's it. Then we return 1. I love it. Buffer.h. So this will eventually support the other stuff as well, but for now we'll keep this nice and simple. Gif tag AD test. Nice. So if we go to draw2d.c, instead of all this stuff, we can go gif tag AD test, pass in our state, and then pass in 2, right? Just the magic number that we set this to for disabling the z-test. And then we can grab out, yeah, so we can get rid of this. You're gone. And then we keep the draw clear. So what happens now if I build and run this? Does this work? It compiles, that's good. And it works. Oh, doesn't that feel so good? And you can see we're setting this to a different value. Doesn't that feel so good? Doesn't that just feel so good? Okay, so draw clear. We're gonna simplify again, right? We're gonna simplify again. We have a function for drawing a rectangle, so let's just do that. Let's do it. Let's do it. Where are we? Frame start. Let's just do that. Draw 2D rect. And we're going to pass in 0, 0, 640, 480, right? We also need to draw 2D, set. What are we doing? What are we doing? Set color. We're going to set it to now. What is it? It's state dot something. It's not even in this file, is it? Draw 2D, draw.h. I need to know where we store the clear color. What have I called the variables? Literally just clear. Okay, that checks out. Clear 0, clear 1, clear 2, except it's state.clear. And then 0x80. The magic number for alpha, it's hard to explain why this is opaque. It just is, right? And then we draw a rectangle in this color. We get rid of this clear screen thing. Oh, except... Actually, yeah, no, but we don't even have to think about like the offset and stuff. This is all taken care of for us by other things. So we do this, and we just do this. So what happens if I build this and go? Unused variables, man. What if I run? This looks good. This looks good. This looks perfect. Why is this going so well, right? If we look at these buffers, look how small this buffer is now. Look how much simpler this is. Has anyone answered my question about PS2 SDK clearing the screen? Not yet. Not yet. I'm not expecting an answer tonight, right? I can be impatient, but I'm not that impatient. Look at this. Look at how much nicer this function is, okay? So we start our frame, we disable z-test, we just draw a big old rectangle to the screen, and that's fine. And now, well, again, I want to, rather than doing this like direct manipulation stuff, this is okay, but why not just say gif tag new state 0, 1, 1 gif reg ad len gif reg ad. So rather than just like doing this, oh no, we do use draw finish here. Yeah, no. So why draw finish? Gif tag ad finish, right? We can just set it here. We can just set it here. Buffer.c, come in here, int gif tag. Colt Zero, good evening. How you doing? Welcome to the stream. This is probably going to be a shorter stream tonight. My microphone stand broke, which is why I'm sitting really awkwardly. My posture is not good. I don't want to damage my back. But thank you for stopping by. We are trimming the fat. We are going down to the rawest level we can, I guess. So, you know, we've already done all this stuff at the raw level. We're cutting out the higher level functions from PS2 SDK that we don't need because we've already done the work, right? It's good. It's really, really good. Struct d2d state, and this is it. We don't pass any arguments here like before. Gif ad gs reg finish, and we just set it to 1. We just set it to the magic value of 1. We always set this to 1. There's nothing else we would ever do with the finish register. You never set it to 0. It just gets magically set to 0. Buffer.h. Perfect. Alright, so if we go back to draw2d.c, we can cut this out. We can cut this out. And that sounds beautiful. Hold on, what's this mem copy? That's good, yeah. Okay, and now if we run, something went wrong. If we run, something went wrong. Okay, so, I'm gonna force this to rebuild and see what it says. It looks okay. So what went wrong? Let's look at this buffer, okay? This is not an end of packet. Oh no, this is an end of packet. Oh, some thoughts here about Unreal Engine on the PlayStation 2. Were there any Unreal Engine 2 games released on the Gen 6 consoles? Almost certainly, right? Yeah, like Unreal Tournament. Interesting. Yeah, there must have been. There must have been. I just can't think of what they would have been off the top of my head. I don't really know. Like, there's a bit of a nebulous gap. I'm a Quake guy, right? So my knowledge of Unreal Tournament games is lacking. My knowledge is lacking. Let's Google this real quick, right? List of Unreal Engine games. Unreal Engine 2. America's Army. Remember America's Army? Okay, so maybe even... Let's go by year. Unreal. Magic the Gathering Battlegrounds. Oh dear. I mean, literally, we've got a list of... Oh yeah, 13. That's a game, right? Had a really, really bad re-release recently. Magna Carta? Interesting. Not many, right? Not that many. Yeah, Tom Clancy stuff. Brothers in Arms. There's a game I haven't thought about for a long time. But yeah, really not that many, right? Feels like maybe was coming in towards the later days of the PlayStation 2. The Windows version of Harry Potter and the Prisoner of Azkaban uses it, but the PlayStation 2 version seemingly doesn't. Interesting, yeah. It's a good engine, right? There's a game, that was made in a version of Unreal Engine 2 that released in 20... Yeah. I mean, look, if you know the engine, right? Skyrim, basically still just the Morrowind engine in a lot of ways. Use what you know. Love what you know. Okay, so we're going to undo this real quick. And we're going to build, and we're going to run, and we're going to look at what this buffer does differently. 7, 1, 8. So was this here? This is an important number, right? We're going to look at this. D. So let's actually copy this buffer out. We might as well. Let's put this in a window. Cool. All right, so we're going to redo some stuff. And if we build, if we run, we crash at the end. Well, not crash, we stall forever at the end of the first frame, because if you never finish drawing a frame, the PlayStation 2 will just hang there forever. Okay, so we look at this part of the first DMA tag. This tells us how many things are in the DMA tag, and we look at this to see if we look for this to be the same. This is the same, that's good. What we really want to see is the first difference. So it looks like this is actually fine. 800. Now there is a 1 missing here. Okay. Number of loops, number of registers, number of loops. One of these is 0 when it should not be. So let's just set this to 1. Let's set everything to 1, right? Oh, hold on, did I? Yeah, sure, okay. So if I run this now, I'm guessing it's gonna... No, this is still a... Oh dear. I don't even know what that bit is. I don't even know what that... Hold on. GIF buffer.c GIF tag new. Flag loop and a packet end reg. Okay, so flag should be... flag should be 0? Sure. We'll say flag is 0. Number of loops is 1. Number of regs should be 1 as well. Huh. Regs AD len. Ender packet. So it's almost like having ender packet set has somehow corrupted this. So what if I set ender packet to, well, not 9. What if I set it to 0 and I build and run this? Then we still have a 0. Something's going wrong here. Game made in version of Unreal Engine 2 on the PS3 360. It would be technically possible to port the game from the PS3 to PS2. Not necessarily, right? Like, assets and like memory constraints, especially memory constraints and texture memory constraints on the PS2. Like, maybe the raw game code, sure, but there's definitely like more to consider, especially when it comes to older consoles where things were like heavily optimized around the hardware. The fact that there are any engines that run on both a PlayStation 2 and an Xbox blows my mind, right? Let's take a quick breather and have a look at the Melbourne skyline right now. I've been checking out this live stream. It's really cool. You should have a look at them if you want to see. This is a low quality camera from the skyline of Melbourne as we speak. So you can see, like, still a bit of sunlight. It's crazy. There's still a bit of an orange glow in the sky. And yeah, there is the iridescent sprawl of of the Melbourne city up along the Yarra. Thought people might like to see that. Thought people might like to have a little taste of where I am. That's not my apartment or anything, right? That's just some guy's apartment in the city. I definitely don't live that high up. I wouldn't cope. My partner and I inspected a place when we were looking to start renting this place. We inspected one on the 8th floor somewhere, and that was too high for us. We went out on the balcony and we were like, nope. It was just like windy and I don't know, it felt very high up, right? It was not great. Okay, so draw 2D. What's gone wrong? What's going on here? Why do we have 0 loops or regs? I can never remember which is which. So if I go back to buffer.c, right? Loop reg. Lower. So the lower part, or end loop. End loop's the part of the bottom. Reg is the part of the top. So what we're saying, if we have a packet that looks like this, we're saying there's nothing inside this. So this is then read as the next DMA tag, and it's nonsense. So nothing happens. We either crash or just stall forever. So we need this to be a 1, and it's concerning that this isn't a 1. So what I think might be happening is the kick function isn't cleaning this up properly, potentially. Maybe. Let's set this back to 1. That's because we know that's okay. Does draw2d kick update last tag loops? So this should be working. It calls all this stuff. It calls all this stuff properly. It calls all this stuff properly. Gift tag new. It really doesn't like this for some reason. It doesn't like rolling out. So let's go to draw 2D. Let's go to, sorry, draw and draw 2D kick. Okay, so we'll trace the kick starts. Let's actually go to update last tag loops. I jumped past the definition. I got too keen. Okay. Oh, we actually do this already. So let's check out what's happening inside this tag, right? So allocate, blah, 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 clear buffer, DMA tag, gift tag, rectangle, gift tag, rectangle. This is the thing that we draw. Then we should make another gift tag after this, right? Frame end, yeah, gift tag. So this is the finished gift tag. We kick this, update. Last tag loop 0. Now this is the problem, right? Something is not updating our number of loops. Something's not updating our number of loops. Oh well, not even is it not updating our number of loops, but it's actually overriding our number of loops in a really bad way. Where is it? So it's saying that there are 0 loops. Like when we create the tag, we say, hey, here's a tag with 1 loop. And then for some reason our state says, hey, here's a tag with 0 loops. And then when we call this function, it's wiping out the loop that we already told it is there. That's not good. That's not good. So if I go to buffer.c, okay. Shouldn't this increase the number of loops? Why does this not increase the number of loops? Loop count. State.gif. Okay, so hold on. All we do is we come in here and we say s loop count plus equals 1, right? This is what we do. This is all we do. Hold on. S gif dot loop count, right? We just build this. Control reaches end of non-void function 139. Return 1. Build. Run. And this looks better. This looks much better. Why does this not work now? This looks right. This looks like exactly what we want. Let's come back over here. If I just... Okay, so this is the same. The DMA tags are good. The sandwich at the start and the end is good. This gift tag, perfect. Now if we come in, where is... So this gift tag is good. This gift tag is not good. We're doing something wrong here. We're doing something wrong here. It could be that... Oh, it could be that setting... No. No. Okay, we've got one thing too many. The game you're talking about, I Am Alive, started development in 2003. Oh no. 2009, passed on to Ubisoft in 2010. That sounds like a nightmare. That sounds like some Duke Nukem Forever stuff. What engine was Duke Nukem Forever on in the end? Was that a... I don't know. I vaguely remember I Am Alive coming out though. Right, I was still a PS3 gamer back in those days. Okay, so we have one too many loop, right? We have one too many loops. Or we have one too few loops. We're not calculating the right number of loops. Why is this 2? Because we're drawing 2 triangles to do this rectangle. 1, 2, 3. 1, 2, 3. Yeah. That's really annoying. You speedrun it. Nice. Nice. I Am Alive. That game really does ring a bell for some reason. Oh, the Mud Pig, thank you very much for the follow, by the way. Sorry, I missed that one. I was jumping around to all my different windows. Yeah, nice. Yeah, that game actually does look familiar, Cold Zero, definitely. Alright, we're gonna get this working. We're gonna crack this. So we're somehow calculating... Somehow changing that has messed up this calculation. That's weird, right? Or was that wrong before? So if I go back up here, right? And I get rid of this, what happens? What happens to this number? It's still 1. But it should be 2. When did this change? How did this change? Is this because... Oh, hold on. This is actually a really boring bug. If I go back to draw2d.c, right, I go to frame end. So in drawKick, there was all this stuff about updating the last gift tag, right? Like finalizing the last gift tag. But then hold on, gif buffer.c gift tag new. One of the things this should do is update the previous gift tag, right? Maybe not. So what's this thing called? Update last tag loops. Draw2d update last tag loops. Maybe this should be part of gift tag new. This would almost certainly be part of gift tag new, but now it works. Now it's beautiful. Now it looks fantastic. So let's test this out with a more involved example. We'll test out our palette renderer, and this looks beautiful. Nice. This is running. This is hitting like frames and stuff. This is good. This is a nice Pico 8 color palette thing. I love it. So that's good. So we now no longer depend on PS2 SDK for setting up our frames and drawing our frames in C or Lua. We now just do it all with our internal code, right? So we use our own gift tag abstraction to do it, to manage it. That's a lot better. This is probably going to have to change. We might end up doing what PS2 SDK does as soon as I learn why it does it that way. But for now, if it works, I'm in no rush to do that. And this is just really, really good. So there was a warning here, right? Something about this Z buffer. Let's get rid of it. We'll work out how to manage the Z buffer when we come around to it. That'll be when we start doing 3D, which is getting very, very close, by the way. We'll work it out. We'll have to get there. So I should be able to get rid of, if I go into buffer lua.c, I should be able to get rid of draw and build, and this should be, okay, that's not good. Oh, hold on, no, I'm not quite there yet, am I? There's still some of it when we end the frame. No, yeah, so end frame, these now no longer live in the buffer, right? This is gone. Start frame, end frame, you're gone. You no longer exist. Start frame, frame start. And I like it. I actually had a comment about this saying it was a hack. I can now delete that line saying it was a hack. That feels good. That's the kind of thing that feels really good to do. Start frame, end frame, you're gone. Completely gutted. Look at this. Okay, so now let's just head back over. Let's go to PS2 init, I guess. Let's run this with our slow 2D renderer. I love it. We can actually see log lines coming out of our Lua source, which again is beautiful. A little bit of wobbling at the bottom here. I think this is how we handle our frame buffer. So this is a fairly like high priority for what for things to fix. And you can see just like a little bit of shimmering and stuff. We can work it out. We can work it out. We're clever. We'll solve it. But yeah, that's beautiful. That is absolutely beautiful. So if there are a few things to clean up here, aren't there? If I go to rect.lua, no, I got rid of that. That's good. But we can probably get rid of trace level logging, right? Info level, perfect. So what do we call this? What do we call this? Let's say draw 2D, Lua and C cleaned, no longer depend on PS2 SDK draw. Cool. So then there is that one little bit left, okay? That one little bit in gs.c? gslua.c, right? This one little bit that sets up our draw environment. So this is going to be something to tackle another day. This won't be hard, it's just a few little things, and I think actually if we run we should be able to see it, right? This buffer should get kicked off if we enable trace logging. Let's maybe go back to rect. Let's go back to trace logging. I really need a better way to run these things that doesn't involve changing this line. If you're thinking program arguments, that is a really honorable thought. But if you have a look, the only argument we get to this program ever, no matter what I do, is the name of the elf itself. And that is the same no matter where I seem to run it. Even though in theory PS2 Link supports arguments, in practice it doesn't seem to actually pass anything. Load some things, blah, blah, blah. First, no, maybe not. Maybe that first buffer doesn't actually get logged, because it's not really a proper buffer, right? Spider-Man 2 was developed on Unreal Engine 2. I didn't know that. What version of Spider-Man 2? Is that like the PS2 version, or a different... Is there only one version of Spider-Man 2? Am I going crazy? Okay, let's go to gslua.c, right? We build this buffer when we first set up frame buffer and stuff. Set buffers, okay. So I build this thing. Let's do... Is it called print buffer? Literally called print buffer, except it's not there anymore. I think it's in utils.c, right? Print buffer head q minus build it, run it. Cool. So now we should be able to see that first buffer. Yeah, so we just need to set these registers, right? And there's a bunch of registers to set. There's 16 of them to be exact in the setup environment call. And then, yeah, like finish and kick it off. And then there's also this. What's 18? I don't even know. But yeah, so just a bunch of registers we need to set that it's just going to take a little bit of time to do them all. And it might be more interesting to do them off camera. This is interesting. What's 44? Let's find 44 real quick. Let's find it from the source. That's a little bit easier. What did I say? 44. Dimex. Dither matrix settings. That's cool. Yeah, PC versions in UE2, console versions in Treyarch. That's like, you know, seeing the different engines for different versions in that era is definitely not uncommon. I think I'm going to have to start to call it here because my back is getting sore from sitting awkwardly because my microphone stand broke. unfortunately. Bit of a tragically short stream, but we achieved something really cool, right? This is important. So what I want to do with this, I want to take this, I want to start with literally an empty source file, and I want to build up how PlayStation 2 graphics work from scratch. Essentially recreate this and show people in a more educational way than me just like blindly experimenting with it. Now that I understand it and can do it from scratch, sit down and show people how to do it themselves and how to start playing with these things and how to start drawing triangles on a PlayStation 2. I think people would really enjoy that kind of content. So if you have ideas for what you want to see with things like that, definitely send me a message. My email inbox is always open. My Discord is always open. I don't know if I have a link to my Discord on my channel. I really should. Few things to clean up. I also need to set up a Discord bot at some point. But I'm rambling on. This has been fantastic for everyone watching this VOD on YouTube. Thank you very much for tuning in. I'll catch you next time.